Hey, physics babies. Sorry I'm out. If you forgot that I was going to be out, I'm really sorry. We've got a pretty straightforward lesson that I'm going to go through today. I'm going to show you how to solve a couple problems that are a little bit more complicated, but you will get a lot of practice with them in class together. So I'm just going to show you. I want you to take down notes, write down any extra questions that you have about solving those problems, any concerns, honestly, anything that you want to ask me, make sure you write it down. And then your classwork is going to be solving a set of problems that I think are a little bit more straightforward. They're a little bit less complicated to begin with, just to kind of make sure that we are freshened up on all of our math skills. So without further ado, let's get started. Okay, so I posted these problems on Schoology so you can access them as well, but honestly, it's plenty if you just want to copy them into your notebook, because we're going to be doing math, right? We need to have our notebooks ready to go because it's going to take you 5 hours to try and type all of this out. So our first problem, this is a formula for acceleration, in case you were wondering, and we're going to actually use this a ton our first semester here, honestly. So we've got A for acceleration equals VF squared minus VI squared, all divided by 2 delta D. A is acceleration. Anytime you see a V, it's for velocity. F is final, I is initial, and then delta D is displacement. Again, all of this is things we will talk about in detail in class. I just didn't want you to think I was pulling some random set of letters out of my butt. So this problem specifically, we're going to practice solving for VI. So we are going to practice getting our initial velocity, that letter VI, all by itself on one side of the equation. Step 1, I am actually going to rewrite this equation so I can see it a little bit better, because if we're being honest, sorry guys, it's honestly not that clean, but I think you'll be okay. I don't have any room to manipulate this formula like this. I need to rewrite it so I can show my work. If you like drawing your line, the belt line, as some people call it, go for it. I don't care. You don't have to, but if it makes things easier for you, definitely do it. You need to solve the math on your own, so you need to do what you need to do to be successful. If we are trying to get VI all by itself, remember, we've got PEMDAS, but we're going backwards. So the first thing we look for is any addition and subtraction. By the way, if I didn't say this before, you should be taking notes and following along with this problem. So if you need to rewind, restart, and take notes to follow along, please do so. Pause me whenever you need. First thing we need to do is look for any addition or subtraction. I see we've got subtraction right here. But, whenever you have a fraction, I want you to imagine that the numerator and the denominator are in their own little individual sets of parentheses. I can't mess with this subtraction right now because it's in parentheses, and parentheses is the last thing we look at. So I don't have any multiplication or division. I'm sorry, I don't have any addition or subtraction. Moving on, multiplication, division. I see there is some division, so I'm gonna undo that division. To undo division, we have to multiply. I'm gonna multiply by this whole thing because why not? It's easier. Why make more work? The more you can crank out in one step, as long as it's a good, clean, fair step, the better. So whatever we do to one side, we have to do to the other. So these will cancel, and we get 2 delta D times A equals VF squared minus VI squared. Now, yes, this is in parentheses. However, now that I just have the numerator of my fraction, there's no need for those parentheses anymore. I can eliminate them. We're going to start all over. We look for addition, subtraction. I see I've got the subtraction going on, so I need to get rid of this VF. I want to get VI by itself, so I'm going to get rid of this. Look in front. What is happening in front of this VF squared? Technically, there's an invisible little plus here. So if I've got an invisible little plus, that's addition. How do we undo addition? We have to subtract. And whatever we do to one side, we got to do to the other. These will cancel out. I'm going to rewrite this whole thing over here so I have some space. We've got 2 delta D A. Whenever the letters are just next to each other like that, we know we're multiplying, so I'm going to get rid of the little multiplication symbol just to clean it up. Minus VF squared equals negative VI squared. Don't forget that this was here, okay? You have to bring it over. Okay, we're almost there. I see this negative in front of VI. I want to get just VI by itself. We're looking for that like addition subtraction again. Technically, this isn't addition subtraction, it's a minus. Okay, but it's multiplication division, right? This is a -1 that I'm multiplying by VI. How do we undo multiplication? With division. Those go away. Because it's a negative sign, and it's a -1, I'm going to take each piece and just divide it by -1. 2 delta dA divided by -1 is -2 delta dA. Negative VF squared divided by -1 is going to be a positive. Negative and a negative make a positive. And then we get on this side just VI squared. The last thing we need to undo, if I have a squared, how do we undo squared? With a square root. Those cancel, and so we end up with VI equals the square root of -2 delta dA plus VF squared. I'm actually going to take this and I'm going to extend it out a little bit, and I like to do this little brackety deal. That way I know everything that's in here in front of this little line down is inside of that square root symbol. This is a personal preference. I just think sometimes if we write it like this, square root of, 2 delta dA plus VF, like I forget to extend it, and then like we don't know exactly what's going in that square root. So just a preference, you do you. But if you make mistakes because of it, then I'm not going to feel bad. You got VI all by itself. There's nothing else complicating it. We are done. We have solved this problem. Whew, that was a lot. If it helps, I promise it's easier once we start having numbers, which we're about to have. So pause the video now if you need to take any notes on this, jot down any questions, and we will go over this problem again the next time I see you if there are questions. Cool? Cool. Clearing my drawings. Clear. Okay, so we can scroll down to the next one. Oops. So this next problem is asking us to solve for our unknown variable, but instead I'm actually given values. So I am telling you that the acceleration in this problem is 16 meters per second squared. I can tell you that the delta D is 3 meters, and I can tell you that VI is 2 meters per second. Great. We have the same formula that we're starting with. Now that I know my givens for this problem, this is an example of our givens, I can take them and plug them in to my equation that was selected. Generally, you'll be responsible for selecting your own equations, but like this is just an example to practice with the math. So here we go. I'm going to take this equation and I'm going to plug in these values. So it's not A anymore, it's 16. Listen, your units are very important. However, do not try to throw your units into your math. All it's going to do, honestly, like from experience and both as a student in physics and as a teacher, trying to throw your units into the problems is going to confuse you. So leave your units out until the very, very end. We've got 16 equals VF. Okay, VF, I don't know. If I don't know it, I can't just ignore it. I have to leave it as VF squared. Minus, okay, VI is next. That's a 2. So I'm going to do 2 squared divided by 2 delta D, so it's 2. My delta D is 3 times 3. Perfect. So step 1, we are just going to do whatever easy math we can. So for example, I see 2 times 3. I know I can do that. I know I can do 2 squared. Let's get it done and make this a little bit simpler. 16 equals VF squared minus 2 squared. 2 times 2 is 4 divided by 2 times 3 is 6. Okay, cool. Up next, trying to isolate my variable. I'm trying to get VF all by itself. So I have to start doing some inverse operations. Remember, PEMDAS backwards. Now that we are solving for a variable, looking for addition, subtraction. Oh, but this is in its own set of parentheses. I'm not going to touch it. Looking for division and multiplication. I see division. I'm going to undo it with some multiplication. Oh man, I should have picked my numbers better. 6 times 16 is 60, 70, 96, I believe. If I mess that up, first person to catch me wins a prize. VF squared minus 4. Oh wow, I actually did I did a really good problem. Oh my God, look at me go. I never do this well when I guess numbers. Sorry, okay, so now, we've got VF squared minus 4 equals 96. We got to get this 4 out of the way. It is being subtracted, so I'm going to do addition. Those cancel. 96 plus 4 gives me 100, and that's VF squared. We need to take our square root to undo that squared that we got there. So I now know that VF equals positive or negative 10. I say positive or negative because depending on the problem, whenever you take a square root, you wind up with this plus or minus because 10 times 10 is 100, negative 10 times negative 10 is also 100. Your problem, when we put these into context, will let you know if it should be a positive 10 or a negative 10. But for now, we don't know. We're just going to leave it plus or minus. And then the last thing we're going to do here, because this is still a physics problem, is we're going to slap some units on it. If you had to guess, what do you think the unit should be for VF? V is velocity, F is final. Let's look right here. Oh, our initial velocity is in meters per second, so our final should also probably be meters per second. And we are all done. Look at that. That wasn't so bad, was it? Again, take a picture. Or pause the video. I'm about to clear off my drawings. Make sure you've got all of this in your notes. Make sure you have jotted down any questions about any of the things that I said, any of the steps that we took, etc. I am here to answer them, just not until the next time I see you. Sorry. Okay, clearing that. So now that we've done some practice, this is your work for the day. You are practicing your algebra skills. As you can see, I have the answers provided for you. The answers are there for a reason. I want you to solve the problems and try to make sure that you find an answer that matches up with what's provided. Especially in math and physics, I'm a big fan of you being able to check your work pretty immediately because I don't want you to practice something wrong 10 times before it gets fixed. With that being said, like, no work, no credit, right? This is a final answer. And if this is all that's on your paper, I know that you didn't actually do the work. You just looked at the answer key. And that's just not going to fly. But I do want you to be able to check yourself. I want you to be able to figure out, like, okay, like, I didn't understand this one. I need to ask this Popp, or I need to get on Zoom or FaceTime or whatever the hell you guys do with a friend to ask questions and make sure that I understand. So answer key is available. Use it. Show your work. All right. That's it. So your exit ticket, you need to actually submit that homework. It's going to be due by midnight tonight. Shouldn't be too bad. It's only, I think it's only 15 problems. Should be pretty quick. And I think they're a lot easier than the ones that we'll actually see in class. I just want you to get that practice of doing math. So that's it. If you need anything, reach out. Please be flexible. It might take me a hot minute to get back to you, especially this weekend, because I'm just going to be out of it. But I am still here for you, and I love you tons. And yeah, have a great weekend, a great long weekend. I can't wait to see you do great things. Okay, bye.